Okay, awesome. Welcome everyone to the 127th meeting of Systems Thinking Ontario. This is the first meeting of 2025, so Happy New Year's to everyone. We are on a different weekday on this particular one. Here we are on Wednesday evening, but moving forward, because there's been some schedule shifts specifically related to the program, the systems course in the Strategic Foresight Innovation Program. We're going to accommodate a couple of schedules. Some of the schedules February onwards will be Thursday evening. So we'll post that notice as well. But this session is called Generative AI and Inquiring Systems, Ways of Patterning and Ways of Knowing. And we're going to start off with a brief set of introductions by the group, as we typically do in Systems Thinking Ontario fashion. And then we'll land with David and Nishat, maybe describing what they're going to cover on this topic. So David Ng will be the discussant and Nishat will be the co-discussant. So I'll start us off by just, asking, going around the virtual room and just asking yourselves, what brings you here this evening? So you can just say hello in a very, very, very brief intro about what brings you here this evening. So I'll start on the grid system that I have here, Dan Ng.
Yeah, Dan Ng from Toronto. I guess what brings me here, generative AI, you pick a better topic. So I'm pretty excited about how David's going to kind of bring it into the world of systems thinking and changes and all that stuff. So looking forward to it. Thank you.
Wonderful. Kelly?
Oh, hi. I'm coming into systems via Peter Jones and through David Ng, and I'm part of the core team of System Changes Learning. I come in as a change professional. I don't text know my background, so I assume that I will be in a listening mode for this one.
Awesome. Welcome. Elena?
Hi, Elena Leonard here in Toronto. I don't know enough about AI and I'm eager to learn.
I think this will be a great session for that. Welcome. Peter Jones.
Hi, everyone. Peter Jones, professor at OCAD. I'm in Toronto for this month, so happy to join and learn about some of the updates to different AI tools that might be explored. And this may be the last session I can join until the Design for Health course, which is on Wednesdays, is done in April. So glad to be here.
Wonderful. Welcome, Peter. Next up is Rose.
Hi. I don't know what there. I'm from Ottawa. I'm happy to be here to listen and learn. I know a bit about AI. I'm looking for that linkage, as Dan said, about with systems thinking.
Nice to see you, Rose. Thank you. Shui Tang.
Hi, good morning from Myanmar. Actually, it is strange that that email came to me just recently. I saw, okay, AI and system. So I think how AI can be used in system analysis, I think it is very interesting for me. I mean, operating, probably actually using system thinking and also, practicing OD in Myanmar and for Myanmar and in the region for many years. So I think it should be very interesting. So I just actually click and then I just jump in to really learn it here together with you. Thank you very much.
Yeah, thank you for joining. That's part of the benefits when we do host these virtually on occasion. We get folks from around joining us. So happy you're able to make it. Thank you. Panagiotis.
Hi everyone. Happy to be here. Παράγοντας Παναγιωτακόπουλος. I'm actually at Seneca. Well, I'm the last year and been changing roles to be one of the AI thought leaders. So I've been focusing on AI the last year, but I also teach at OCAD the Sustainable Now Business Design course that's about to start on Friday. So very excited about that.
Awesome. Thank you for being here. Next up, Roberto.
I'm an SFI, Strategic Foresight and Innovation student at OCAD right now, taking my master's. And I heard about this and I was like absolutely on board, would love to know more about systems thinking and especially as related to AI, because that's what I'm hoping my MRP will be, because that's why I left my previous position, because I saw the systems just changing in my entire former industry, which was media, and how that's going to impact everything. So that's why I'm here today.
Excellent. Thanks for being here. Nelia.
Hello, I am a SFI grad, and it's nice to see some familiar faces. I'm here because I'm very interested in AI, and I sort of work in that field, in the AI field. So I wanted to see the intersection of systems and AI. Yeah, that's about it. Thanks.
Awesome. Penny. Penny, you're just on mute. We can't hear you here. I'll hit that button for you.
I'm being a techno peasant as usual. Okay, so I've been a student of educational cybernetics since the 80s when I did my master's, and formal and informal student. And I'm quite skeptical about AI since reading Fernando Flores. But I want to hear what you have to say about the intersection between cybernetics and AI.
Wonderful. Rose K.
Hi, it's nice to be here. I haven't been here in a while. I'm interested in AI from a regenerative economics perspective, so I'm interested in hearing about the connection. It sounds like a great topic.
Nice, welcome. Jenya?
Hi, everyone. Yes, just also curious to hear about intersection or, whatever that is between the generative AI and systems thinking. And I kind of know David and here today because Dan prompted me and sent me the link. So nice seeing everyone.
Nice to see you. Thank you for being here. Tim, what brings you here this evening?
I just sense of urgency, I guess, to kind of get on what seems like it's going to necessarily be a long and winding road of learning and such at the intersection of all the things in the heading of this talk. The heading could easily just have been changed to, a riddle wrapped in mystery inside an enigma, frankly. It's sort of a parallel system, I would say. But anyway, so just urgency to get on any and all opportunities for people to talk about these things is probably really good and important right
now. Next up is Zareen.
Hi everyone, I am strategic foresight innovation student from OCAD. I'm right now working on my final year project, which is related to AI as well. So that's why I'm here, and I'm also curious about how to link up between AI and system, because I think AI is a very broad topic. Also, I'm very interested about ethical AI, which is something that I'm really dive into right now. So nice to meet everyone.
Wonderful. Welcome. Daisy?
Hi, I just glad to be back at the Systems Ontario meeting again, and the topic is very interesting, so that's why I'm here.
Awesome. Thank you for joining. Sandesh?
Hey, yeah, I've been following AI. I've been in the software field for quite some time, and AI is pretty much all over Twitter, LinkedIn, related to stuff. But it seems to me that there's two camps. One are like proponents of AI, but they seem to be focusing more on the now. And there's this other camp which is like focusing on AI in the future, and they are the pessimistic side. So it'll be good to see views that might encompass both in this meeting. So also a student of Open University, pursuing my MSc in systems thinking.
Gotcha. Okay, wonderful. I heard a lot about the Open University, so glad you're able to be here.
Sure.
Yeah, Thank you everyone for sharing. I forgot to introduce myself. My name is Zad Khan. I'm also a graduate of the SFI program. And yeah, I'm similar to all of your answers almost. I'm also interested about the intersection between AI and systems. I guess in a deeper way about even at the core philosophies, what can we enact that might not have been possible in previous decades where this technology wasn't as advanced as it is now? What does that mean for systems? So that's my kind of inquiry. But I'm going to turn over to David and Nishat to introduce themselves and maybe set the stage for what we'll chat about today. And we'll go from there.
Okay, thanks. Let me share my screen. Okay, and let me move this off here. Okay, so I've been playing around with generative AI for a little while. I've been trying the open source ones, installed it, and so Zad is one of the people on the receiving end of me learning this over a long period of time, which is try this, try that, and it's like, okay, let's try to put it all together and make some sense of this. The reason it's called, well, firstly, generative AI, people know the technology, and then the inquiring systems part. I haven't actually given the first System Thinking Ontario talk. Actually, it was before System Thinking Ontario. It was at a Design with Dialogue. I'd given a talk on inquiring systems, and so that was like 2012. And then I went to look for slides, and the last time I actually presented inquiring systems was 2018. So there's a little catch up here. But there is the design of inquiring systems by Wes Churchman, and Mitroff have done a lot of work on that. So I'll explain that. And I'm going to actually do this as a live thing. There's a few slides here so we can kind of guide ourselves. But generative AI to me is ways of patterning, and I'm very focused not so much on the text to image, but I'm mostly focused on text to text sort of things, interpreting that. The ways of knowing are associated with the inquiring system. One of the things that we're going to focus on in the OCAD class is what is the system of interest? And in this case, we're not just looking at the technology itself. We're going to be looking at the technology with a person or in a group. And so the question is how those things might or might not work together. So the way I'm going to start this off, I have two slides here, and I'm going to talk about ways of patterning. And I'm going to try to make some sense of this by kind of describing it like a recipe collection. For those of you who are in computer science or in data management or those sorts of fields, then we can have discussion afterwards. I'm sure Nishat will give me some opinions on this. I'm just trying to try to make this easier to understand about how it is that we're looking at artificial intelligence, or maybe better, intelligence augmentation, IA, because what we're trying to do is use information better with human beings. So the first thing, and the typical way that we would actually organize data or organize information, is in a hierarchical physical categorization. So normally, before we had all these computers, you would have a library, there would be a physical book. And so what you would ask is, where can I find a cookbook in the library? And you end up with the Dewey Decimal System, you end up with the Library of Congress system, whatever, but it's organized in a hierarchy where it says, oh, philosophy starts at 000, economics, I think it's like 658 in the Library of Congress. And so you have all these things, but it's organized in a hierarchical way, top down. And so when we used to have databases in the old days, for those of you who go back to relational databases, you had to decide the structure of the data before you build the database. And so in that case, we would have, you'd have a key, could be your social insurance number. In this case, looking for a cookbook in a library, you'd have a library card number. And with a library card number, and then you've got the cookbook number, okay, you've got that match, and this is how you actually organize things. What happened when we got the internet is you got the second thing, which was web crawling and keyword indexing. This is actually a little bit backwards, because you could say, where can I find a recipe with this ingredient? And this is a case on the internet. The shift that was made was from structured data, that hierarchical physical categorization, into firstly a lot of hashtags. Now, people are used to hashtags, and so why would you have a hashtag? Well, you're trying to separate out the words that make a difference from those that don't make a difference. At a certain point, it's kind of like they figured out how to do that programmatically. So when you get all the ands and thes and those sorts of things taken out, which words actually make sense? But the idea when the internet came, we're back in the days of Yahoo, Excite, all those sorts of things, was web crawling, which will read the whole internet and then we'll do a keyword indexing. And so if we say, I'm looking in the refrigerator, I have okra and I have a tomato and I've got, I don't know what, but it's like, where can I find a recipe with these ingredients? There's a good way of looking at it. Now, you couldn't do that in the old days of cookbook because all the words would be on all the pages. And so you have to start with, oh, I want to cook this recipe. Oh, then I don't have the ingredients. You could do it the other way now, which is go backwards and say, okay, I've got these ingredients. What recipe can I find? The third change that came, and this is where Google started, was backlinks to PageRank. And as opposed to keyword indexing down on all the web pages, what they did was they said, let's look at all of the web pages, and the way we're gonna weight them is that the more people that link to that page, the more important it is. So if you are a person that put up a web page, and this is why blogging actually became important. If you put up a web page and it never changed, and I come back a year later, and it's the same page, I come back a year later, and nothing's changed, I'm not going to be very interested in that. So people started blogging, and it started creating new content. Every time you come to a page, it's different, or it changes in a week or a month or whatever. People can see a website is still alive. But when you have that idea of PageRank, it's not down to the keyword, it's what page is it on. So the question you could ask is, which recipe pages are most frequently cited on the internet? And so you get, in effect, now you get into SEO search engine optimization, the people trying to get more people connecting to your page, and that way it becomes more important. Along the way, we started getting into machine learning, pattern recognition, and this is at the foundation of data science. And what happened in data science was that you would take large data sets and you would try to figure out where clusters would be, or try to differentiate, so where you can demark things. And so an example, which ingredients most frequently go together? And so, tomatoes, onions, and celery, it's kind of like a lot of things go together there. But, they started doing some weird sorts of things where it's like these flavors actually go together really well, or these flavors are usually not matched together, and maybe they clash. So machine learning and the pattern recognition and the data science was done more as advanced statistics, because you're looking at frequencies and those sorts of things. But the change that happened with data science was it was not pure statistics in the sense we normally think about statistics, because they try to optimize for machine learning. And the sort of thing, because I took a data science class, I took one at Ryerson, and we got into this sort of question because I'm used to actually doing a lot of things with logarithms, and so we do natural log, log base E as an example, and they go, everything is log base 2. They do binary. It's like, well, that's mathematically not correct. And they say, well, the difference between log base 2 and log base E is very small, and it's close enough. So they go, mathematically, though, it's much faster to calculate on binary than it is on log base E. I go, okay. And so I did the research, and there's about 5% difference when you actually start working practically on that. So the machine learning is now getting towards looking at data and trying to figure out what patterns are in there. And it's not necessarily the most accurate. It's not like coming in like the hierarchical categorization, which is, oh, I know that these categories exist and things fit in these slots. It's much more of, there's a book called Everything is Miscellaneous. So you have all these things gathered together and you're trying to cluster them together and you're looking for that. And then the clusters are not necessarily all tied together. And so that idea of pattern recognition is like, well, when is it close enough that you would actually say that it's part of this cluster, as an example? Okay, so starting in the 2010s and today, we start getting into more of the neural network sorts of technologies. And so natural language processing, and this is the work that's at the foundation of a lot of the neural network ideas. We have this idea of back propagation weighting. So when you're working with text, the question could be, what's the likeliest next ingredient in a recipe? And so this is why they start calling them language models, because when you're working with language, you're trying to figure out what the next word would be. And so we're used to being in browsers now, you go to Google and you used to type, and they had a type ahead. And so you could actually see the word, because Google is trying to anticipate what the word is you're going to search on, type in next to be searched, because it'll speed up the response for them. And that's the sort of thing you would get if you work through the data, because you see that people have their own vocabularies, use certain ways, and then you actually get the idea about what the next word is. So in a recipe book, it's like, well, after you put in the onions, what's the next ingredient? What's the likely, and then if you put in, I don't know, curry powder after that, then what's the next ingredient after that? Number 6, recurrent neural networks, and going to text generation. The idea of recurrent neural networks was an extension of the work that was done in natural language processing. But this was a switch when they started having the Watson machine on Jeopardy. And there was a switch towards question answer technologies. And so what's important here is not just the analysis of the data and knowing what the next ingredient is going to be, but being able to reconstruct whole sentences or stories or paragraphs associated with that. So an example of this would be, tell me a story about making an apple pie that a 5-year-old could understand. So firstly, the technology is able to actually create a story about an apple pie, but you start getting into things like sentiment analysis. So it's like, we want this at a 5-year-old level, or we want this written for a doctoral level, or we want this written for a mother that doesn't have time, or all these sorts of things. Now, these are all language tricks, because how does it know what a 5-year-old writes like? Well, if you're actually searching enough data, you can start to categorize it and work those things out. But the difference between the original natural language processing, which in effect was input, and then you do something with it, is when you started getting into the text generation with the RNN, it's like it will respond to in the question answer sort of mode. Number 7, self-attention and transformers. For those of you who are using the word chat GPT for everyone, GPT is a general purpose transformer. And so this is the technology that came and is the one that everyone's woken up. What does a transformer do as opposed to the natural language processing, the backprops? So normally the way that they work out the algorithms is they're trying to figure out what the next word would be. But the actual interesting problem that they started working on was translating from one language to another. Now, my understanding of Japanese is that Japanese like to put the verb at the end of the sentence, not in the middle of the sentence. And you have all these things like in Chinese, there's no verb tense. And so you can't map necessarily the word order in every language the same. So if I ask, summarize the main points of this Japanese cookbook for me in English, you can't just go, well, the first question is, in Japanese, what would the word order be? And then in English, what would the word order be? And it's like, oh, that's an interesting problem. So what we do now is that we actually do what's called self-attention. We actually put the weights so that it figures out what the most important words are. You have the decoding and the encoding parts again. So you have firstly understanding what the prompt is when someone says, oh, summarize the main points of this for me. And so what do you mean by summarize? What do you mean by main points? But then you've also got it reassembling with telling the story at the end. The 8th one, now what happens with the transformers and chat GPT, GPT and all of those type of tools is that they work on training. They take a large language model, they take a large language data set, a corpus as they call it, and then they read it, and then they encode it, and then they have a version release. If you're reading the whole internet, which in effect it does, then the internet changes. But it's like, well, okay, how much of this would you actually care changes? It's interesting when I was working at IBM and they first brought out the AI group, and I was sitting in a sales group. The first people that jump on the new technologies are the finance people. They go, "Oh, new technology, we can make a lot of money off this," and then you go, "Wait a minute, no, in finance you make money off the increments, off the minute, off the second. You don't make money off the last 100 years data." If instead, if you look at medical text as example, the body of the corpus of information on medical knowledge is so large that, just adding on the new journals, like, yes, there are new journal articles that come all the time, but if even the AI engine would probably update more frequently than a doctor would read the journals. And so when you're looking at the context, the idea of the transformers would be, okay, in effect, and this is where systems come in, we're going to take a snapshot. We're going to assume a closed system at this point, and that we're going to use that and read in that information. And then you're going to ask this closed system. And so if you ask, well, what happened in yesterday's news? The response should be, I don't know. I was trained a month ago. But it doesn't do that. It actually will make things up because it's trying to help you by answering the question that you asked. And so if you actually ask a question, and we'll do this kind of in the demonstration as we go forward, you run into this issue that this is not as efficient as a search engine like Google created, because Google is constantly crawling the internet and updating the indexes. But what happens with the transformers is you actually have to recode the whole large language model. And so that's why when they announce a new release of GPT, it's such a big deal. Oh, they understand better. They've done these tweaks and they've done all these weightings in it. So the eighth one, which is the new hot technology, is retrieval augmented generation, which is adding new context. So in this case, we understand the transformer, and the transformer is fixed on this amount of data. And you go, oh, here's a new cookbook you haven't read. Summarize what's new in this cookbook. And some of the engines, it depends on, I'm only demonstrating free, what's free to consumers today. Some will say, sorry, I can't read your new cookbook, or sorry, I can't find it on the internet. Others will go, okay, I can access that and I'll get it for you. And now I know you want the newest cookbook in there, so I'm going to add that in. Other ones will say, well, we don't want to mess around with copyright or anything. So what we're going to do is actually, you give me the data and I'll read it in, and then I'll summarize what's in it. So those are kind of the 8 ways of explaining data. And I'm going to do a chat challenge in a moment, but I'm going to stop for a second, and I'm going to invite Nishat to comment on this.
Yeah, thanks, David. Very good introduction to data processing and pattern recognition, by the way. Sorry, my camera is not on. I apologize. I can't seem to get my camera to work today. So that was a very good introduction, David. I think you got all the points right from the days of the old library searches and having information in a thesaurus or a library, like a Library of Congress, right down to like the most modern ways of retrieving information from retrieval augmented generation. So I think in most of these cases, I think the most salient point is that there are ways of patterning data. So it's not an inquiring system as such. I'm not sure if you have any points to add over there, David, but I don't know if there is a real system of inquiry or an IS, as Wes Churchman would put it. In all
we'll
these.
get there. Not yet. Just trying to level the ground on the technology right now.
Okay.
Okay.
Are there any other questions from the audience? Just I know we haven't gotten to the chat exercise yet, but are there any other questions about the groundwork of the 8 technologies that David shared? I think we're all just kind of waiting, David, to see how this goes in application. So maybe more questions will pop up once we see you run this fun exercise. So I know I'm excited to have a look to see how that goes.
Okay, this is the dangerous part of the exercise because I'm going to do this all live. Okay, so what I'm going to do is we have on the right here a variety of different technologies. And so people kind of go generative AI, and you kind of go, I'm thinking, well, which one? And so OpenAI has ChatGPT, which most people have heard of. Microsoft Copilot actually takes ChatGPT engine, takes the ChatGPT version, and then does its own indexing on top of it. So in theory, you should get the same answer, or you shouldn't get the same answer. We'll find out. Mistral Le Chat is French, and so it comes from a completely different code base. Anthropic was founded by some people who left OpenAI, and so they have a different technology. We have Google Notebook LM, which is pure RAG, and we'll get into that, and Perplexity AI, which is one that I'm using a lot today, which has a lot of the RAG features. But I'm going to actually use AI in itself, and I'm going to ask this question. When choosing large language models, when would an inquirer choose a transformer over retrieval augmented generation or the reverse? And so to do that, I'm going to actually drag over, let me bring up this window here. I'm going to drag over this window. Oh, can't do that. I have to stop the presentation. Oops. And drag over this window. The whole window. Come on. Here we go. Okay, so I'm going to start off with ChatGPT. And here's the question I'm going to ask. And so one of the things that you'll find in all these classes who want to teach you something is they're going to ask you, they talk about prompt engineering. And so when you ask a question, the more precise the question, the better the responses are going to be. And so I'm going to paste in this question that I actually asked. And I'm going to ask ChatGPT. So ChatGPT is going to think about it. Okay. Okay, there's a lot there. Wow. Okay, would you like a more technical breakdown? Okay, well, this one is actually quite long. Okay, choice is between when to choose. Creative content, content summarization, sentiment analysis, transformer only, pre-trained knowledge sufficient, task beyond reasoning, input text. And so I'm going to come back to this because I'm going to try a different approach. I'm going to go and bring in Microsoft Copilot. Now, this is supposedly also on the same ChatGPT engine. Oops, sorry. Okay. Now, this one is shorter. Now, I could have asked it for longer or shorter, but I've actually been using Copilot a lot. Actually, for the classes at OCAD-U, we've actually been requested as instructors to use the Copilot because there's a little more filtering that goes on. But let's talk about what they have here. Okay, when would use a transformer? General language understanding. Okay. Resource constraints, a static knowledge base. Okay. When to choose retrieval augmented generation. Dynamic information needs. If you need updates, accuracy and relevance. So if you have critical information or specialized knowledge. So you hear about companies today that are adopting large language models in their businesses. And so there's a combination because you don't use just a transformer or a RAG. You tend to use both of them together. You use at least the transformer for the language. And you get this interesting split between the transformer is really strong on language, but the retrieval augmented generation, the RAG, is really strong on content. And the question is, can you separate the language from the content? And you go, well, that's pretty messy. But if you were, as an example, doing a contact center, insurance company, having people phone in, and you have an automated agent at the other end, you might want to steer more towards retrieval augmented generation, because you would have the corpus being all of the answers that are in all the procedure manuals, all the helps, all the questions that have been asked by customers before. And then you go, okay, there's the base, and we just need to actually figure out in that data set what it's going to be. And we don't want actually language. We don't want the hallucinations that come out of a transformer model. We don't want it to be creative. We actually would like the retrieval augmented generation to say, I don't know. But from a transformer model, I don't think will ever say, I don't know. Because you ask it a question, it's going to respond to the best of its ability. Okay, so let's try this with same question, chat. Okay, complex understanding, reasons about data availability. Okay, this is a completely different code base, a different training. For those of you who don't like the American branch, you could try the French branch. There's a lot going on about technologies and open source. And for those of you who have been following the sagas of OpenAI started off as a open source, not-for-profit company. And the question comes, open source traditionally has been about code and that is executable and repeatable. And if it's not repeatable, then how would you actually work through that? So having just the code to create the data doesn't necessarily include all of the data in which it was trained. And so there's a little bit of issue in that. In the French case, they have not yet made it open source. I don't know if they're going to make it open source. And there's advantages and disadvantages. The question is, do you trust them or don't trust them? But if you don't like American companies, you could try that. The people at Claude, so these are the renegades that left Google. And they answer the questions in another different way. Would you like me to elaborate? And you can always do this. One of the things about working with AI and in a conversational mode is that you shouldn't always assume that it knows that you're going to get the right answer the first time. So when you're working with traditionally like Google or search engines, you actually usually have keywords and you assume that you're going to get the right question. You want the right question. You should like the right answer the first time. The expectation when you're working with an artificial intelligence engine like this, for me, is that you really have to engage it in conversation. So you might think when you're going to deal with this, since I use normal search engines like I do, if I think I want to get the answer right the first time, I think I ask one question, one answer, like, what time is the store will close? It will actually do that correctly. If I think it's going to be more involved, where it is multiple tries, then I will use the LLM. I'm going to switch over here to Notebook LM. Now, this is an interesting technology from Google that's come out. And this one is a pure RAG. And so in this case, when you started off, and so if I go back here, I started with an empty notebook. Let me find the empty notebook. Okay, there's the first thing. It starts off and it's an engine that has no data in it. And so like I can't even ask a question until I add some data sources. And so, okay, so I'm going to go back and so what I had done was I had taken the two technical papers that are the most well known. And so this one is the 2017 paper on transformers. That is like really hard to understand. The name of the paper is Attention is All You Need. And the other paper was Retrieval Augmented Generation for Knowledge Intensive NLP Tasks that came out a few years later in 2020. And so in this case, there are only these two data sources. And if I ask anything about what's the weather or stuff like that, in theory, the RAG should come back and say, I don't know. But what they've done here is that they've actually created some different documents. Let me bring this in. And so we can have a briefing doc. Let me go down here. And so what it'll do, it has push buttons, and so it'll actually analyze the data for you. It'll create a study guide. It'll do all these sort of things for you. But the feature everyone likes is that it will actually create a podcast for you.
David, we can't hear.
Yeah, we can't hear it, David. I think you might have to change your settings.
Okay. I can hear my headset, but I can't hear it.
Okay. If you unshare, David, and reshare with audio.
Where? Okay.
Oh,
sorry.
Where's that setting?
Share sound. Okay. This one work?
Okay.
Especially for someone like you who's already familiar with this field.
Right.
We'll start with Attention is All You Need, which introduced the game-changing transformer model. Then we'll move on to Retrieval Augmented Generation, where we'll explore how these models can tap into massive knowledge bases like Wikipedia.
Attention is All You Need really was a turning point. You know, remember how traditional sequence models like RNNs struggled with those long-range dependencies in language?
I do.
It was like trying to run a marathon while carrying a growing stack of books.
Wow.
The further you got, the harder it became.
Right, because those earlier models processed words one by one in a strict sequence.
Yeah.
It makes sense that they lose track of the context as the sentence got longer and more complex.
Exactly.
Yeah.
The transformer, however, completely changes the game. It relies solely on this attention mechanism, allowing it to look at the entire sentence holistically, figuring out which words are most important to each other, regardless of their position.
So it's less about the order of the words and more about understanding their relationships.
Yeah.
Is that where the scaled dot product attention comes in?
Yes.
I've seen that term thrown around a lot.
That's the heart of it.
Okay.
Okay, I'm going to stop with the scaled dot product. For those of you who have done enough algebra, it's kind of like, okay, we're into math now. But what I'll tell you, all I did is I took these two documents, I dropped them in. I actually went through and created some briefing documents and timeline, FAQ. So I'll push the FAQ button here. And it's actually creating a new FAQ here as we go along. But then I created this audio overview. It took like a minute to generate it. And then if you really want to not read and you want to hear, it's like, there you go. Okay, FAQ generated here. What's the main attention, you know. So this is what I'd actually like, and I hope I'm going to demo this in the class, Understanding Systems class next week, is I do have a reputation for when I teach a class, I give more readings than the students could handle. So one way of getting through that would be, why don't you guys actually drop them in to Notebook LM and get them to summarize it for you. Then you can decide, you can't, it helps your understanding. It doesn't replace your understanding. It may make things easier by simplifying the language in the research papers, because they tend to be written by PhDs and graduate students and masters, you know, these sorts of people. And so the language may be above the level, but you could actually drop into the system and then say, well, could you explain it to me at a grade 8 level, or explain it to me at a grade 5 level? And so the language model, now you can see where the transformer is different from the RAG. The RAG would be taking care of these 2 research articles because that's the content. But then the transformer would be doing the translation where I say, I want this at a university level, I want this at a high school level, I want this at a primary school level. Okay, so I like that a lot. I'm going to show you one more, which is Perplexity AI. Now this one, I'm going to feed in hopefully the same thing. And this one is interesting because if I go back to ChatGPT as an example, it gives the answer, but it does not give any sources. When we're working in Perplexity, it's actually giving me, this is where the sources come in. And so if I scroll down a little bit so you can read it, when choosing between, okay, so choosing transformers, specialized domains, where does this come from? Ah, it comes from that source. Oh, this comes from this source. Comes from just, oh, these all come from the same source, all number 2. And then you come down here and it's like, oh, this one's a different source. Okay. So I'm finding this helpful because I know that it's not hallucinating. And then the interesting part is it has, at the bottom, they have related questions. This is when you really get to understanding the use of AI because you go, oh, as I'm reading down these questions, I realize I didn't ask the question perfectly the first time, and there's actually questions I can now look at. So what scenarios could it be more fruitful? We can go here. Okay, real-time info needs. And again, we have sources. Okay, so that's the end of the demonstration. We've done the 6 technologies. And I'm going to pause and we're going to have a conversation about them. Nishat, what do you think?
Well, very good demonstration. I think you really covered the difference between transformers and RAGs there, especially with the last one. I think perplexity. I think it provides the source as well as it would also say when it doesn't know something. Isn't that right?
I haven't tested that thoroughly, so this is where you get into intelligence augmentation. I think if you ask a stupid question, you might get a stupid answer, but I'm not really sure.
Okay. And do you want to talk anything about prompt engineering?
Why don't you talk a little bit about it? Because you've seen me now, and the reason I asked Nishat, he's actually a computer scientist. So why don't you talk about prompt engineering for me?
Okay, I think prompt engineering is very important in LLMs, and especially when dealing with these models, because you know it's really the way a transformer works is it has an encoder which takes in input from the user, or in other words, prompt. And then it has the neural networks, and ultimately it leads to a decoder, which is what works on the output. So for a transformer, or even for a RAG, I think the way that the prompt is sequenced and inputted is going to determine the quality and also the value of the output that comes out of it. And so if you want a really good answer, it really depends on how good the prompt or the user prompt is. The level of detail and the level of preciseness is actually matched to the quality of the text that is in the input of the encoder. So I think for especially when you're dealing with ChatGPT, I mean, to get more and more precise and better answers, one has to kind of give it better information, encode it better, and keep improving the prompts, giving it or asking it for more and more precise details. So I think prompt engineering is where all of that really plays a heavy role.
I think there's a lot of people now selling AI classes, and a lot of the AI classes are about prompt engineering.
Yes.
So then, David or Nishat, what would be the systems angle or perspective for a hypothetical AI class in systems? What is the kind of the value overlap that we're kind of exploring here?
Oh, then let me go back, and I'm going to share more slides. We'll move on to inquiring systems.
Okay.
Unless any other questions on the technologies? Yeah.
Before I ask a question, guys. So the sense I get, okay, so you got the transformer, which generates hallucinations, the RAG, not so much. And I thought to myself, and the questions that you've been posing is either or. But let's say you run both of them. Otherwise, maybe what you do, and I don't know if this makes sense, you take the output from one and feed it into the other. Does that make sense in any way? Is that something that's done?
So you need the transformer just for the language, because knowing what sequence the words go in and knowing which words are important are something that are built into the language model. The RAG limits the data set on which you're doing it. And so again, this was the issue about in effect language versus content. And so you say, oh, I want pure content. Well, if you I can do you pure content. Like I can write like a math equation that no one's going to understand. Or a PhD level is very, very precise in that language. And so if we took the attention as all you need article, which is written by PhDs for PhDs, and it's like no one's going to really understand that. So, but that is very, very precise. So the language model in the notebook LM is trying to simplify just the language, not change the content. But then if it kind of gets down to that block then about, well, how much information can you put in a RAG? And Notebook LM is free, and people should try Notebook LM. It's a lot of fun to work on. But I think Google actually currently is limiting it to 50 input sources. But then it's like, if you really have 50 input sources, can you actually parse them apart? Like with those 50 input sources, you can also select and deselect what you want to do with them. So there's always going to be firstly, there's pure transformer, right? And then RAG has come along to correct some of the deficiencies, but you always need the transformer to do the language. Does that help, Dan?
No, what I'm suggesting is make it an iterative process, right? That you get the large language model, the transformer to generate stuff. You feed it like back to the RAG. You see what happens there. I'm not implying that it's like a one and done, right? I'm implying that perhaps it could be an iterative process, so that when it generates these sources, you generate enough sources, then you feed it back to it. I don't know if that makes sense. It's I'm trying to understand. I understand how ChatGPT works, and the hallucinations is absolutely right. It's very good at creative, and that's okay. But sometimes I like to know that the stuff it's created is kind of close. So what you do usually rely on domain expert, right? The domain expert yourself, maybe you look at it and say, no, that was nonsense, right? But I was just thinking, there's no opportunity for that. It's got to be either or. It can't be, more nuanced.
So let me describe mathematically what happens when they do a RAG. So there was a lot of work associated with it called vector databases. And it's interesting that when we think about search engines, we actually think about creating a hit. You want to make it like exactly on the dot. You want to hit the bullseye in the target. What happens with a vector database, and this is what influenced the RAG, is that they create, in effect, vectors that are close to each other. So what happens is that when it answers a question, it chooses that one vector. Then the next question would be, what is the question that's closest to that? So when we're looking at perplexity not only came out with it answering your question, it said, here are 5 questions that are close to what we think you're asking. So that's still staying within the RAG technology, but now we're getting into the question answer dialogue and the feeding the RAG back into the transformer. You could do that, but I'm not sure that's going to create more accuracy, because what you're trying to do now is move along a line of reasoning. And when you get that first answer, there's multiple directions you should go from there.
Yeah, I guess what struck me was I heard the word prompt engineering, and that's why I thought that, like, isn't that what you're trying to do actually? Like you generate something. I mean, if you look at it the way I use ChatGPT now, I ask a question and it, I throw it at it, and then I look at the answer and I go, well, that wasn't too good. So in my mind, I'm the RAG guy here. I'm the guy that's looking at that stuff and trying to figure out, okay, that didn't work, and like send it another prompt. I don't know. Isn't that what we do?
Okay, I'm gonna let me go on a little bit and come back with the question after I do the inquiring systems, because it's going to show like what in effect I'm doing with that domain is I'm going to do prompt engineering on it. I'm going to be very, very precise in the questions I ask. So I'll come back to this, Dan. Okay.
Thank you.
I have a question, if it's okay.
Sure, Nishat.
So one thing I wanted to ask was about updates. I mean, internet and all the forums and all the information on it is constantly being updated every second. So when ChatGPT 4 came out, this was in May 2023, it only had been trained on the data up to May 2023, right?
Right.
So it doesn't have access to papers or books or updated Reddit articles, etc. after 2023. So if you, in effect, if you ask it a question, if you ask a transformer a question, it only has access to the data up to that little point, up to 2023 or 2024. And if you ask it a question, it's probably going to creatively hallucinate or confabulate information. How does Notebook LM deal with that problem? I mean, is there a way to is it updated, or or is it still have the same problem? Can it still confabulate or come up with answers where it really doesn't know the answer?
It restricts it to the data that you provided. And so when I started Notebook LM with an empty notebook, the first thing it did is ask what data source you're going to use. Like it can't move forward until you do that. So you have to put at least one data source. So I'm going to show that a little bit more. So let me continue, and then we'll see if I get some more questions answered. Okay. So pull this off here. Okay, so we were here. Okay, I'm going to talk about the design of inquiring systems now. An inquiring system, and this comes from Wes Churchman's work, and Ian Mitroff was a student of Wes Churchman, who improved on it and made things a little bit simpler. The basic idea is an inquiring system is a way of knowing for human beings. It's about generating knowledge. So there are 5 ways of knowing that Churchman created. I'm going to do the first 4 on the slide. The first one is an inductive consensual inquiring system, and this is the first way of knowing. And it's based off objective views of the world. So in this case, what we do is it's inductive and consensual. So firstly, we're inductive, which is what's happening here. The typical sort of thing is, I can't see, but how tall is Zad? It's hard to see him on a screen, but like we can all guess how tall he is. You can, and then we're going to take these answers, and we're going to actually create this bell curve of it now. And the Delphi approach, what it does, it takes these answers and starts cutting off the tails and refeeding it in. So in theory, we should be able to answer this question, how tall is Zad, based off the opinions. Now, since we can only see Zad on screen, it's not reality. This is inductive because we're feeding in our knowledge of Zad. I actually don't know how tall he is. I haven't thought about it very much, but okay. And then it's like consensual. Whatever we decide is true. And so this is kind of the world is flat argument. If we all observe the horizon and we think the world is flat, the world is flat. Now, we can extend this all the way out into the ways that, I hate to say, misinformation comes about, because how do we know what's happening? Like, how do we know if Donald Trump, when he says he wants to annex Canada, is actually saying that for real, or is he just joking? Well, what we would do is, okay, we could take a vote on it. We could take a poll and say, how many of you think you think he's joking? How many think he's for real? And then it becomes that reality. So that is inductive consensual. That is the typical way, whatever majority rules, this is how we decide. That's one way of knowing. The second way of knowing is an analytic deductive inquiring system. In this case, scorecarding is usually the way that we do an analytic deductive. So an example would be, we want to hire someone for a job. So we have this objective. We say, okay, we have these agreed criteria. We're going to score the people on, their skill level, their people abilities, their technical abilities, whatever it's going to be. We're going to score them and give each one of them a rank, and then we add them up or multiply or weight them, whatever. But the idea here is that we have a scorecard where picking the best candidate for a job is whoever gets the highest score. And this is a mathematical way of doing it. It has logical consistency. Now, we use this so often, and going through the job prospects is a really interesting discussion, because Russ Ackoff said there's another way of approaching this, because what we're doing here is we're starting from the abstract, and you're saying there is a perfect person out in the world, we just have to find them. But what happens if there's not a perfect person in the world? So Russ Ackoff goes the other direction and says, well, what we could do instead is say, we have these candidates, and it's going to be the COO for the company, Chief Operating Officer for the company. If we hired this guy, what would he do to the company? Because there you're working from the concrete to the abstract. And so I don't know how many people have actually worked through a job prospect like that. It's kind of like, I remember at my job at IBM, because I was doing a lot of market development work, I would say, you want to call me when the customer doesn't really know if they're going to buy into the technology at all, but you do not want me there when you're actually trying to close a sale, because I open too many questions. So you have to get the context right, and and position the best man for the job at that time. And scorecarding is universal. We do it all the time, but it may not actually pick the best candidate. The third way of knowing, multiple realities, inquiring system. In this case, the third way of knowing has the idea that the model and data are not separable. So in the first two inquiring systems, you're actually saying, oh no, there's an objective reality out there. So when we're doing the inductive consensual IS, it's like, oh, that actually does have a height. You could argue how high it is, but he does have a height. Or when you're looking at analytic deductive IS, you go, well, this is a scorecard, and this is a scoring we're going to use. But what happens in the multiple realities inquiry system, it says, no, there's a model and a data, and now you get into experience. And you can't take the knowing out of the person. So Elena's on this call. She knows systems in a way. I know systems in a way. David Hawk's on the call. We all know systems in a way, but we don't all know them the same way. We all have different models, and we also have different experiences, different data feeding into it. So what we do with the multiple realities inquiring system is that we look at a range of views. And so if you do this as a pure Kantian dialectic, what happens is that you can get one person to argue, and this is where you get into debate, where one person will argue black and the other person will argue white. And they actually don't have to believe in it, but if they take the positions and they actually go through that argument, then the person that benefits is the observer, because they see the debate going on and they go, oh, I see, it's not black and it's not white, it's kind of gray. And sometimes it's a little more black and sometimes a little more white, but it's the debate that you should be able to see. So the example I have is like a drug problem, or you want to take medically assisted suicide, these sorts of things, sort of issues. Everyone has a different view because they have different experience, they have different models in their heads. If you try to solve those complex issues in one of the other ways, you don't get expert knowledge. With the multiple realities inquiring system, you actually get experts, and the experts discussing things, and there you can learn from both of them. The fourth way of knowing is a dialectical IS, and this is full debate now at this point. And so the idea behind the multiple realities IS is that you actually get an expert. And so if you're in court, you would call an expert witness, and you get expert witness debating with each other. The dialectical IS actually says that, no, we actually want the conflict in it. So we want to discuss what, as an example, what should Skid Row housing be? How do we deal with people who are homeless? And there's multiple ways of doing that. You could have people, we have the debate today in Canada between the Liberal Party and the Conservative Party, and they kind of discuss it. Now, the difference here in the conflict is whether they would go to another inquiring system as opposed to being in the dialectical one, because the guarantor here and the idea of all these inquiring systems is trying to pursue truth. So what is the truth? How do we know it's true? In the multiple realities inquiring system, you actually have an expert. Expert has experience, and you're saying, okay, what that expert says is true. Medical professional, I go to my doctor tells me to do this, I believe that. If you went to a dialectic inquiring system and you have a doctor, you go, well, the surgeon doesn't agree with the internist. And you start getting into the conflict, and then you go, oh, this gets confusing. But you can actually set it up where you look for that conflict. So there's different situations when you would want each one of those. Now, where we come with each of these is these are all based on philosophies. So the first way of noting is John Locke, inductive consensual inquiring system. The second way is Leibniz, the analytic deductive, so it's more mathematical. The multiple realities is from Immanuel Kant, and Hegel is a dialectic. And so the proposal that came from Wes Churchman, from his supervisor, Singer, was we want to create a systems approach where we have multiple perspectives. We like the idea of the dialectic, the Hegelian dialectic. But the problem with the Hegelian dialectic is that the person arguing black and the person arguing white, they only see that perspective. The person that gets to learn is the observer. And so what we want to do is we want to have everyone debating and everyone observing in a circle. And so the question would then be, well, how is it that we actually make progress? How do we actually know that we've actually gone as far as we can go? In this case, the idea is that you use the other four inquiring systems all together, and the guarantor is progress. So you debate until you no longer actually make progress. When I was at IBM, Steve Heckel had this idea, and he was working a lot at that point with Russ Akoff and also at General Motors. And so they would have this idea of market research. And you're doing market research, how do you know what vehicle at General Motors you're going to build? And the question was, what progress are you trying to make? And we got into this interesting dialectic. Steve Heckel, being at IBM, said the progress for IBM would be customer satisfaction. We want to increase customer satisfaction as it is the vector of progress we want to pursue. At General Motors, they said, no, we actually want to increase profitability. So establishing what the vector of progress is going to be is non-trivial, and so that takes some discussion on itself on top of all this. So I'm going to use the engines now, and I'm going to go through, describe the 5 ways of knowing described by C. Wes Churchman, Design and Inquiring Systems, extension from Churchman's student Ian Mitroff in The Unbounded Mind. Okay, so now I'm going to come back and I'm going to, where's my notepad? Let me pick up that question again. And we'll see how these do on it. So ChatGPT, our new chat. Okay, now here's the first thing I'm going to say is one of the first things I did because I wasn't sure. The question I asked the first time I worked on ChatGPT is, have you read this book? And this one actually, because I'm looking at a 1971 book, ChatGPT has actually read the book. Now, we start getting into the questions of copyright issues, and where did it read the book if it's copywritten? And so those sorts of battles all come up. But we have here what Churchman did, and then what Mitroff did, extending it. So each one of these, so it comes up with these and these answers. I can do the same thing in, let me find Copilot. I'm doing the same thing, start a new chat. And it's reductive. Now, here's when you start getting into stuff. It's like, I don't know where this existential intuitive came from, and I don't know where this historic genetic came from. Like, this is just weird. So it's possible that it's reading stuff, but I think I've read this pretty well, and so there's a little bit of hallucination going on. So Microsoft has introduced something that is not helping. It's actually different from ChatGPT that was actually pretty good.
I think hallucinations are the sixth way of knowing.
Yeah. Okay. Let's see how the French have done on this. Okay.
So, David, how do we know it has actually read the book?
Well, we're also going to get this. Okay, now we have this actually. We have this again. So this is quite interesting because the sixth way of knowing, I have not seen Ian do this. And we actually had a conversation with Ian for a long time. And so I would like to know where it got that, but it can't actually tell me. So so answer your question, Nishat, the reason that I know it read the book is because I've read the book. And so the question would be, is this a good summary? And so as an expert, I'm looking at it going, okay, this one up to this point is good. I don't know where this comes from, the existential inquiring system. I really don't. So there's another way of doing this, which is, let's see.
Searching on that term and reverse engineering and seeing what Minority Report was arguing that the personal experience was the equivalent to one of the other inquiring systems. I hadn't seen it either. That's weird.
That is weird. Okay, so here I asked the question here. So this one, what I've done is I've loaded in PDFs of the design inquiring system and the unbounded mind. They're copywritten, so I just happen to have copies. And so let's see here. In the ChatGPT, multiple realities, conflict dialectic, unbounded system thinking, which is the fifth way of knowing. And so that doesn't have the sixth way of knowing.
I think is it from, I don't want to interrupt, but is it from the dirty rotten strategies, David? Because I see that existential word come up in that body of work.
That maybe.
You've even transcribed it yourself where he refers to Ian refers to existential crises, and maybe the chat GPT system is pulling that and it's thinking that that's an inquiring system.
Right. Good, Zad. So yeah, so when I said I wanted to restrict it to these two books, the other engines are pulling Ian's other work. So that could be an answer.
Quick question out here at this point. I'm saying, how certain can we be that it's reading the original works versus derivations, maybe opinion pieces or reviews or something similar, which is going to touch upon the same material and, put a spin of the author's perspective on the original text. So how can we be sure that it's actually reading from the original itself versus some of these derivatives?
Okay, so this one in Notebook LM, the only two data sources I've given it are these two books.
Okay.
So in this case, that's very limited.
Right.
Now, if I go to let's see, perplexity. Let's start a new thread. Okay, see how perplexity does. Now, perplexity is actually picking stuff up off the internet, so it's more than the books. 1, 2, 3, 4, 5. No sixth. Although we could ask the question, how does Mitroff's extension differ from the original 5 ways of knowing? See if it comes up with a 6. Emphasis, complexity, interdisciplinary, multiple perspectives, ethical considerations, adaptability. Okay, but these ones actually, you can go back to the sources. And so what's funny is that one of them is me. This is my blog post. But this is actually that's actually from Ian's book. So yeah, so it's reading, Perplexity is reading me. But my stuff is I have it on open access, so it's fine to crawl the internet. Okay, so let me go back to a more challenging question. I'm going to let's see, slideshow. Okay, so we're here. Okay, I'm going to take this question because now we get into the value of inquiring systems. The Canadian government has previously funded nuclear power plants based on CANDU reactors in the 1950s. By 2025, expertise in its commercial production of nuclear power industry has declined. Applying the 5 ways of knowing in the inquiring systems of C. West Churchman and Ian Mitroff, describe how a decision on choosing small modular reactors for Canada would be made. Okay, now this is going to be a real interesting test. And I'm doing this live. It's not like I've done it the first time, but let me pull this up again. And so this is now responding to some of Nishat's questions and Dan's questions about the use of RAG. Do I want a new query? Yeah, let's do a new query. Start from scratch. Okay. So should the Canadian government try to do something with small modular reactors or not? Okay, so ChatGPT says the key question, looking for the question, what's the data say? Because it's actually looking inductive consensual, right? Technical feasibility, economic analysis, global benchmarking. That's they did this out of order. So this one is the second way of knowing. Analytic deductive is actually the second way of knowing. The Lockean inquiring systems, what the stakeholders agree upon, so that's inductive consensual. The Kantian model, this is the expert opinion and the way they would approach that. Dialectic conflict, what are the opposing viewpoints? Pro-nuclear versus anti-nuclear positions. And then the pragmatic adaptive one, because Hungarian is pragmatic, what works in practice. Okay, and they have 5 ways of knowing summarized. Oh, nice job. Summary, start with this one, engage that, do that. Okay, let's play around here with, let me bring up this one, new chat. Let's see how Copilot does on this. Analytic deductive, so it's using more consistent language, multiple realities, dialectic, systems approach. Shorter answer. I could ask it to give a longer answer, but I won't at this point. Let's go to here. How did I do this? Okay, let's actually do it this way. I'm going to do perplexity. New thread. Okay, so now it's actually going. You can see where it's getting the source from. These are all action plan. That's actually going to the Canadian sources, and let's see what it does from them. So mathematicals. Okay, cost benefit analysis shows up in this sort of article. Indigenous communities and experts come in this one. Kantian, this is the experts. Different article, World Nuclear. Hungarian inquiring system. No sources here. So it's staying on the, it's not actually doing the, triggering the RAG here. It's actually just staying with the LLM, with the transformer. And this one, strangely enough, seems to have some answers. Okay, so I'm now going to try one more question. Go to the slide here. Okay. Now, since I read the Globe and Mail every day, on December 24th, there's an article by Matthew McLean as construction of the first modular reactor looms, prospective buyers wait for the final tally. And here's the article. Can you update your response based off that? Okay. So I'm going to take that prompt. Let me pull this up. And I'm going to try it and see what happens, because we know that these engines are not updated, right? So I'm going to try this. Now, we know that ChatGPT has not read the Globe and Mail on December 27th because it's happened afterwards. Or has it? Twitter. This is interesting. It didn't do this yesterday.
It might be doing a workaround. So you look at what people have second comments of the article, and then is doing deductive of deductives, perhaps.
Yeah.
Although that one is odd, that times one.
Yeah, this is interesting. I literally yesterday I tried this and it said, no, I'm not gonna. I haven't done that. Okay, let's try this one. So this is Copilot. Okay. Now, in this case, it's just regurgitating the same thing that it had before. So it is not taking anything about small modular reactors really that we didn't know. So OpenAI appears to have read more sources. They're going outside of the sources, but I don't see any citation there. Let's go to perplexity. It's thinking. It's thinking about whether it has or hasn't read. I'm not really sure. Okay. Has this read it? Or is it going to take it into account or not? No. Well, maybe. Number 7, what's this source? It hasn't read the article. Doing a little better, but I don't know whether I should trust this or not. Okay, let's see if on Notebook LM, did I actually create this? Let's see here. Inquiring systems. Now, I actually have the article. Do I have the article? Yes, I have the article. I'm going to actually add this as a source. Whoops. I have to do it the hard way. Notebook LM. Inquiring systems. Add source. Drag and drop this in. And then I'm going to ask the first question. Now, this may not give a good answer because the Globe and Mail article is one source. And so it's going to base most of the work off this. But this has interesting sources here. Let's go back here. Okay. 5 ways of knowing. Source 1, source 2. Okay. I'm not sure that I and Mitroff was around long to write anything about small modular reactors, number 11. Toffler, no. Okay, so here's a case where I put in the one article, and it doesn't know anything about nuclear plants except for the Globe and Mail article. So this may be a reflection of what you had said, Dan. Is okay, if you want to know anything about inquiring systems and just this one article, then you've got it, because it focuses down, but now the search is so narrow that it's not necessarily helpful. Let's go to, actually, I think Claude. Now let's go back to perplexity. I've lost my perplexity window. Okay, let's start another one. Perplexity. And the threads I had before. Okay, so there's the one I had before. And what I'm going to do is tell it I'm going to upload the text. Let me upload the text. Okay. Maybe not. Attach text. Here we go.
I think, did you choose the right file there, David? Was that?
Let's see.
Looks like you chose the systems.
I think I did. No, maybe I didn't. Clear. We'll do it again. There we go. Small modular reactors. Okay, now you can see DWRX 300. So this stuff is obviously coming from that article. Okay. So I'm going to pause for a second here, and what do people think? Nishat?
Yeah, David. I was just trying to follow up.
So I've taken the inquiring systems now, and I've used that as a framework, because inquiring systems and the way you structure the language, in effect, is a language trick, right? So it's 5 different ways of prompt engineering, in effect.
That's right, David. Yes.
Right.
Yes. That's what I think I learned today. That's really good.
Now, one of the things about these different approaches you can see now is, if, as an example, the second way of knowing, like if you're an engineer and you're taught to deal with data all the time, the second way of knowing is the way you're going to explain stuff. But my father is not a data person, and so he asks people what they think. He's much more inductive consensual. So if I was going to take sources to him, it'd be much more like, my sister and my brother agree, and so therefore we should move forward to do this. And you go, okay. So there's different audiences that will respond to different types of approaches.
So I have a question, and maybe we'll get others in as well, or anyone who hasn't shared, but I'll bridge it back to the systems. David, what applications does this have in systems education?
So I think in systems education, we need to actually have people be a little more critical about the way they think about what is truth, in effect, because all these inquiring systems were about the pursuit of truth. And this is also a reason why, let's take Wikipedia as an example. Why do you not cite Wikipedia? Wikipedia is an inductive consensual model. If the editors think that you're off, you're out. Like you can't put that edit in. So they kind of extend it a little bit, which is, okay, the editor goes, okay, prove it. Okay, I have this data source, which then makes it a analytic deductive. I can back it up. But when you get down to, well, I asked David Hawk because he was a student of Russ Akoff on this opinion. It's kind of like, oh, Wikipedia, that's not good enough. Like, expert knowledge doesn't count. So, but if I have a question for Russ Akoff, I go ask David Hawk.
So the takeaway is being critical of what constitutes as truth. And so, yeah, I wonder, are there any other folks from, someone who hasn't maybe shared a question or a comment about what implications are you seeing from what David shared today? Rose, you want to jump in?
Well, I can add something with respect to the question about education. I think what David has actually done by kind of doing a teaming with the technology to show examples of the inquiring systems and where it gets it right, where it gets it wrong, and learning about the tech while you're going through the process. I think it's an excellent model for a type of pedagogy where the students could use the inquiring systems to construct prompts, maybe even in a structured way, to do their own inquiries and then to show their work supported through the AIs, and then to continue to exploit other references, to dig, like David, you were digging into, 2 or 3 really deep references that you were mining. But I think with SFI students, for example, we'd want them to go broad. We'd want them to, you can direct them to a few things like, Churchman and Mitroff, but so that they at least all have, a common basis and a common language. But we also want them to go far afield and to learn on their own by seeing what other sources they can use for questions they have, not learning about inquiring systems, but using inquiring systems supported by the LLMs in a way as a pedagogical device, and they'll learn about them as they're using them.
Mm-hmm. So we'll go Peter, Rose, Elena, and then David Hawk. So we'll go in that order.
Am I next?
Yep.
Yeah, okay. So similar to what Peter was talking about, I've used ChatGPT primarily, and it was good to see some others there for different things. Editing things that I've written, helping craft resumes, like a whole range of different things. And what I generally have found, it's usually not correct, because I do read everything, it spits out. And so I do like what you said at the beginning, David, about it not being artificial intelligence, but augmented intelligence. So it helps. It certainly helps. It reduces time to craft things. It gets me thinking about other questions. So some of those ones that you used, it asked different questions. I do find results are not always consistent. So I have used Copilot and ChatGPT, and sometimes it gives me completely different answers. So that's okay. It's my role, I think, to sift through all of that and see what makes sense. And when you're talking about truth, I don't know if there's such a thing as truth. I think it's a combination of things, our lived experience, what we learned from others. So I put all of that together, and I don't stop there. Then I show it or discuss it with others, and then it even becomes better. So it's not just me and this language interacting. Certainly the content and formatting it and all that kind of thing. But I would like to know, how's this landing with others or individuals or groups? So it very much is a great tool, because I remember, and probably older than many of you, I remember when Google came out and when we even actually started using the internet. This is going to be the end of the world and humans were not going to have any value. And look what's happened. So I think this we're going through the same thing with AI. Now, certainly, some people's livelihoods are impacted by this because you don't need perhaps editors and writers. Perhaps I still haven't landed on that, or recruiters, or CV writers, or et cetera, et cetera. It's just going to change the nature of how we do things. And I'm hoping, I'm skeptical about the dangers of AI. I think we just need to think about it just like any other tool that's come by our way. Maybe I'm naive, but anyway, I'm just sharing how I've experienced it to date. It could change, but that's where I've landed.
Thank you for that comment, Rose, and glad to hear that it's helped your conversation and that you continue the exploration through conversation. That's really interesting. Yeah, we have Elena next.
One of the things that came up for me is asking it if I were to, make an argument or write a paper, what are the holes in my argument? What are the gaps? And I think that might be, kind of useful, or asking it to, according to one of the, I forget which number it was, reframe this from the perspective of an Indigenous person, reframe this from the perspective of this kind of person or that kind of person. What would they value? So I would see it as a way of maybe doing a broad sweep of multiple perspectives, and wonder if that's a useful application.
David, do you have any comments on that application?
Maybe I'm going to ask Nishat to answer that one first, and then I'll take it. Nishat, do you want to take a whack at that one about whether that would work?
I'm not sure, Elena. I haven't tackled AI or actually these like ChatGPT or Claude from the angle that you have tackled them, like you just mentioned. I haven't really explored that domain of it, like try to answer a question from a different perspective or point out the flaws in my argument. But I think that would be a very useful application. It's just that I haven't tried it out myself.
I have concerns about whether it's possible to do that. One of the experiments that I'm running, which would be an experiment you could actually run with Stafford's work. You could take all of Stafford's work and you could load it into a notebook LM and have a conversation with those books. It wouldn't be a conversation with Stafford, but I've actually been doing that. I actually do have a notebook LM with all of my publications in it, and I haven't played with it enough, but it's kind of like, if you want to ask David Ing a question, could you ask this notebook LM instead? The exclusion, though, is something missing something. I'm not sure that it would do that unless you could actually say, you could ask, how would Stafford actually write this paper? That'd be an interesting question, and it'd be an interesting test. Maybe you should do that for us and report back.
So it looks like Rose wants to jump in on this particular question, and then Panagiotis. So we'll go Rose, Panagiotis.
So, Elena, I've actually done that. Look for gaps, but again, it's limited. So it'll give you a good start, and then you can then go from there. I've also done it from a perspective of, a different person from a different context. Again, I think it's a good start because you probably have read there are biases in all these languages. There's extensive, so I'm always hesitant to do that. It's a good start, but then I would have that conversation with the Indigenous person or audience just to start the conversation. And then I think it would make a richer document or article that you're writing.
Panagiotis, did you want to add to that question?
Yeah, so a few things here about, so David, I tried that as well with Stafford's works, and it was, in my view, it was really exciting it wasn't accurate, but it really depends on what you're trying to do. And I want to weave it in back to, the pedagogy and all of that, right? So my test was almost like a thinking body. So I had a very specific question about, one of, the VSM, like one of the aspects that always troubles me with the model, right? So I asked about that, and it was interesting because it kind of like picked out certain things from the books and gave me a specific perspective that I hadn't thought about. So as a thinking body, I think, like, for lack of a better word, I think it's excellent. And when we go back to the pedagogy thing, I think it's really good when you have like people who kind of already understand the field, but it's a whole other discussion about novices in the field and, how you trust and how it can take you places if you don't really know the thing. And I have another point, but maybe I want to make it later about the modality of the whole thing, because we're talking about text, but I'm gonna ask it later.
Sure, we'll come back to you then. So Jenya, is your question on Elena's point, or is it a new question?
Not a new question.
Okay, so on Elena's point, okay, then you can go ahead, and then we'll go to David Hawk on a new question.
Yeah, sounds good. Because, I was kind of conflicted here. I'm like, are we talking about the usefulness of AI, or are we saying how it's going to be useful for systems thinking? But it seems like we're covering both grounds. So I'm just going to be like on both. So like Panagiotis said, I think I'm using it as a thinking body. And again, if you read, actually, it's about different people function differently. So some people introverts, extroverts, for example, I think out loud. I don't think inside my head. So really important. So like there's a Peter Drucker's article from 1990s, and it's right on the point on that. It's actually every person would be very useful to analyze themselves, how they think or there's different things, not just thinking. So as a thinking body, very, very useful to me. But yes, to me, same questions aroused. There's like, what's the source? And I ask it, where do you, ChatGPT, where's your source? Where are you getting the sources? Give me the top sources. Or sometimes I tell it, go to, top, Harvard Business Review, top thinking, sources, and tell me what are the top thinking sources, whatever that is. So thinking body, yes. And then articulation. I do think, and I don't think it's because I'm like not a native speaker in English. I really think some people are really great at writing, like because it's a different process. It's a linear process rather than a talking process that is more abstract, not abstract. Actually, it's more complex talking rather than writing is a linear process. So I think ChatGPT or AI is much better at this linear kind of processes where, it articulates definitely much better than I could. And then I even talked to my like native English speaker lawyer people, and they said still it can do a better job. On a system side, again, I'm not an expert on it, and it's more like an intuitive sense. But so far from what I'm gathering, so love, David, your introduction of those like 5 decision-making constructs. I would say oftentimes in this society, we are using the one that is this sort of like the expert opinion, or the second one, the decisive, like sort of like eliminating the, based on what is the best. And I think that's too linear. That doesn't account for a lot of complexity. So maybe, relating to systems thinking or complexity theory, it could help if it's trained more to actually provide, because I think a lot of humans in this society are actually trained on the linear more, and there's less of the complex thinking people. So it may help to actually provide that perspective that you're not like deducting things or linearly thinking, but actually approaching things more holistically and having that view. So just connecting to the systems or holistic view side.
I would actually suggest that if we're doing it with students and we're doing with student groups, I would encourage them to use different AI engines and then have a conversation about it. Because the readings are going to be different. With the same text, you're going to have different interpretations from different engines.
So we'll go, thank you, Yenya. We'll go David Hawk and then back to Panos on some net new questions or inquiries.
Are you sure? I tend to be skeptical of everything humans do. And I'm almost ready to drop the word tend to. But nonetheless, there are 3 somewhat interesting articles I come across recently on the subject matter that I think we've been talking about. And they have something to say about the dilemmas in AI. One's called the extraordinary link between deep neural networks and the nature of the universe. And this was found in MIT Technology Review, having to do with trying to understand problems in a superhuman or beyond human way, because they found the way humans understand will not be helped very much by AI, that in essence, the problems may well be locked in by their use of AI. And so that was an interesting article. And second was chaos makes the multiverse unnecessary. And so how to go beyond, again, human limitations, which are expressed in AI, and get on to something else. So in essence, it argues that science, vis-a-vis AI, predicts only the predictable, ignoring most of our chaotic universe. Thus, we have a set of problems awaiting us by ignoring the universe. And that was a rather good article in Nautilus. Another one was, and this is the one that really got me going, because I tend to be an opponent of Aristotle all over the place. And since Aristotle was the basis for computer science, I therein have problems with computer science in general. But there's an article called How Aristotle Created the Computer, which actually is quite a good depiction. And it really goes through the initial people, Claude Shannon and Alan Turing's work, and why that was basis for the computer scientist, and then continues into AI. And so the same limitations they articulated go into that. And this was something that David Ng and I had been long dealing with, which is the limitations of the digital, how to get beyond the digital. And David and I have been talking off and on about both plus more, meaning how do you transcend the digital and get onto the more, which is what the two earlier articles were also talking about. So how to get beyond human limitations. And there's another point which was made by my favorite writer on history, and perhaps favorite philosopher in many domains, in part because this professor I quite liked of Ozbekhan, his teacher, his mentor at Cambridge University was R.G. Collingwood. And so Collingwood kept emerging in much of our discussions about technology. And Collingwood defined history as the lie that's commonly agreed upon. So then taking that definition into AI, which is based on history, that in essence, the historic model is what AI is trying to make sense of and include. But in essence, that basis is a lie. What are we going to end up with? And so I'm rather intrigued by it. And I'll shut up now, but I spent much of the day phone calls, Zoom calls with people that are thinking of taking one of my books and making a movie from it. And they contacted me because AI told them to. So because AI directed, and the book they started out with was the Too Early, Too Late, Now What? And so the producers, the creators of that funny movie called Don't Look Up, I'm not sure if any of you have ever seen it. Anyway, the producers want to go and sort of correct mistakes they made in that, because the movie was originally meant to be about climate change. But then with much research, they found that humans wouldn't go watch it because humans would feel responsible for what the hell they did. And so they went back several 100 million years ago and picked up a meteor. So a meteor would hit the Earth and destroy life, but it wouldn't be humans. You couldn't blame them. So in essence, AI told them to come see me about that book relative to the remaking of Don't Look Up. And we had many discussions today, of which they mostly ended in a book that followed that, which has a difficult word in the title that, David, I won't mention it, but it's a somewhat difficult title and was recently shown, what's the square in New York City? Times Square. So was a 2-minute episode to be shown over and over on Christmas and New Year's, showing that book title and talking about the author of that book. And within a few minutes, it was removed because the city fathers of New York really, really were upset by that book title and image. And so it's now being recast. I won't go deeper, but it has an F word in the title that they were upset by. But in their letter, they were upset not because of the word, but because on the cover there was a small, sweet teenage girl giving the finger to the cameraman. And I selected the picture of a finger with bad nail polish. And in essence, that young girl was talking to we who had created the current world with all sorts of things, including AI, and how she was blaming us for making there to be no future for her. So she was angry at the cameraman and us, but somehow their critique was they wouldn't tolerate the finger. They said nothing about the word, nothing about anything, but City of New York says, we do not allow that finger. And so I sent them a note saying, I understand that it was really bad nail polish, that I'll try to find a picture with better nail polish in the future. And they came back and said, no, that's just not the point. And so then I went back to them with the point being that it was a female that was giving the finger. And if it had been a male, it would be fine. That would be a young man showing masculinity. So it would be a great photo. But the fact that it was a female is a real no-no in New York City. And they stopped talking to me. But anyway, we were using AI off and on during the day to discern what matters, what is true, what is not, who cares. And so this discussion by David was helpful to me because it took us well beyond the argument over don't look up. So thank you, David.
Yeah, thank you for sharing, David Hawk, and glad it was helpful. Just in the interest of time, I think we'll pass it over to Panos and then maybe wind down just from there, as we're almost at 8:30.
Thanks, Wade. It seems like, after David's excellent, deep comment, my comment is gonna be like very superficial. Maybe it was already. But so far, David, the other David, very great representation about, the logic behind these systems, but it was primarily text-based. And I'm just wondering, what happens now with all the multimodal experiences, right? What you just, showcased was primarily text. But I know, I think you mentioned your father, my father as well, it's talking to it like constantly, all sorts of things. Now you can if you have a paid subscription to ChatGPT, you can also see video, so it understands the context, understands to some extent, right? So it gets information from the environment. Probably the underlying logic is the same, but I think there's something to be said about the medium too. And sometimes the medium becomes who said that? I can remember the message, right? So I just find this intriguing as well. I know it's probably we don't have time to explore this, but I think it's the whole experience is different. It's not like typing.
Yeah. So with that, I'm going to actually share and go to the last slide, which will tread on that a little bit. And so this is from Ian Mitroff's 2010 book. And so what he talks about, he takes this quote from Thomas Pynchon saying, if they can get you asking the wrong questions, they don't have to worry about the answers. But he talks about errors. And so statistically, we tend to know about type 1 errors, type 2 errors. So the usual example he talks about is you're testing a drug And does a drug work or does drug not work? So false positive, type 1 error, the test says the drug works, but it doesn't. Type 2 error, false negative. The test said the drug does not work, but it actually does. And so we're used to those. Now, Panos, you've actually taken us into the type 3 errors, which is tricking ourselves, an unintentional error of solving the wrong problems precisely. This gets down to the question about whether you're asking the right question or not, because we get distracted, and this is where we get into helping people, and the prompt engineering is kind of, if you're trained in prompt engineering, it may help us a little bit, but tricking ourselves when we think we got the answer, and it's like, well, it's actually not the answer. So Rose's been talking about it, and she's been critical, and Rose has said it's a good start, but we may be tricking ourselves if we rely on that technology too much. The part, Panos, that you're worried about in type 4 errors is tricking others, the intentional error of solving the wrong problems. And this is malice ideology. And so this is the problem we actually have when people are actually now purposefully tricking us. And so we kind of go beyond the ideas Churchman originally had created of inquiring systems, which was philosophically the pursuit of truth, into the opportunities for errors and misguidance.
I think there's a lot of profoundness to this slide, especially as you increase and land on the type 4 error. It feels like, I don't know if I'm speaking for the rest of the group, but we may need to do a follow-up conversation on AI and type 3 and 4 errors. I think that would be really interesting. And I know, Peter Jones, for example, you've kind of like have remarked about what is a term as 5th generation cognitive warfare. And the information ecologies that we're swimming in and what those do to our minds. So the intersection with AI would be a very interesting topic, I think, for a follow-up from a systems-oriented perspective.
This is great. Now I know where Donald Trump fits. He fits in all 4. He's fantastic.
Wonderful. So we are 8:30, and I just want to be respectful of time. So yeah, thank you everyone for joining. Really appreciate it. I think we've gained a lot of insights. Thank you tremendously to David Ng and Nishat for kind of guiding us through the conversations and the provocations. So that was Systems Thinking Ontario for this session. Next month, we'll be back to Thursday evenings just for some adjustments, and we'll keep you posted online. And yes, the video should go up. Is that correct, David? Like the video will be posted?
As soon as I can.
Okay, as soon as you can. Thank you, everyone. Really appreciate you joining and hope you have a wonderful evening and perhaps even morning for those who are joining elsewhere in the world.
Thank you.
Thank you.
Thank you. Thank you very much. Very interesting.
Thank you. Have a great night.